Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, so this free response is from the College Board. This is in AP Classroom, and so this is really important because I've heard through the grapevine that AP Classroom problems are going to be very similar to the ones that are going to be on the AP. So if we can knock these out, we're going to be ready. Okay, so here I provided you with the answers and everything, but here is all the parts. So it has A, B, C, and D right here, okay? And it gives you this information. So pause the video, see how far you can get. B is very tricky. B, I had a difficult time with, but you should be able to get a bunch of this, okay? So try the best you can right now, see how far you can go, and then I'll do it. And then if you are stuck or anything, text me with any questions, or just do it again and see if you can get the whole thing on your own, particularly part B, because I think is the toughest part, okay? You can do the rest. Ready, set, go. All right, let's see what we got. So here's me doing the problem. Let's see if you got the first part right. So here's the information. I put it down. So it gives you the derivative. It does not give you the actual value. So this is f prime. So at x equals 0, the slope is 4. At x equals 1, the slope is 3.5. At x equals 2, the slope is 2, etc. So it's just telling you the slope. It's not telling you the actual value. But it will tell you this value. So f of 0 is 20. So it gives you that. So it starts at 20. And it tells you that the slope is always between 0 and 7. So the whole slope on this interval is between 0 and 7. Okay. That's what it gives us. A, use a midpoint Riemann sum with 3 subintervals to approximate f of 6. So part A. So I want to approximate f of 6. So it gives me this. It gives me f prime. So I'm going to write f prime, f double prime here as my little chart. So if it gives me this f prime, the slope, and I want to get to the original f of 6, I need to do the integral, right? So I need to do the integral between 0 and 6, because those are the x values, right? Between 0 and 6 of f prime of x dx. So the antiderivative of f prime is f. So the fundamental theorem of calculus tells me that this is f of 6 minus f of 0. Because f is the antiderivative, I plug in the top limit, and then I plug in the lower limit like that. So now I can get this. I know f of 0 is 20, so I can plug that in, and then this I'm going to get through my midpoint Riemann sum. So 3 subintervals, so you can draw a picture if you want, but this is the first one. So the base is 2 and the height is 3.5. So this right here is going to be 2 times 3.5 plus, that's one subinterval. So the other one is going to be between 2 and 4, so that's 2, and the height's going to be 0.8 right there, the midpoint. So it's going to be 2 times 8/10. Plus the third one between 4 and 6, so that's 2, and the height's going to be 5.8. 2 times 5.8. So that is my area under the curve, my estimation using a midpoint Riemann sum. So it equals f of 6 minus f of 0, which is 20, according to the problem. Okay, so I don't know whether you can use a calculator or not, but during the AP, they can't prevent you from using a calculator, so you can just calculate this up. 2 times 3.5 plus 2 times 0.8 plus 2 times 5.8. Okay, your calculator, and you get, ooh, I messed it up. I gotta do it again. It says error syntax. I messed it up, sorry. 2 times 3.5 plus 2 times 8/10 plus 2 times 5.8, bam. So I got 20.2, like that. So I got 20.2 is my area under the curve equals f of 6 minus 20. So I'm going to add 20 there to finish. And so 40.2 equals f of 6, bam. Approximate, oh sorry, it's approximate. There you go. Okay, so that's part A. Got it. Check. Part B. So it's saying, this one's very tricky. So follow me on this. This is one you want to go through on your own after. Determine whether the actual value of f of 6 could be 70. Explain your reasoning. Okay, So it just gives you f prime, just gives you the slope. So how do you know what the actual value is? How are you going to know that when you don't know what the slope is at 0.5 or the slope is at 1.2? You don't really know what's going on. So this is what you do. Part B. Check it out. So the only thing you know is that, so I need to get what f of 6 is. So I know that this, from the last problem, this is f of 6. So I need to approximate f of 6. So when I'm doing this, sorry, this would be dx here. When I'm doing this, I need this right here. So I need these parts somehow to play into my problem. So that's what I'm thinking right now, just like I did up here. So I'm approximating f of 6. So I'm going to use this part right here. So if I know the slope is between 0 and 7, so the whole slope is between 0 and 7. So if I know the slope is between 0 and 7 at any point between 0 and 6. So that would mean that the minimum, if the slope is 0 the whole time, which it's not, by the way, slope is 0 the whole time, then the area under the curve, which is this, right? The area under the curve would be 0. If the slope is 7 the whole time, so the slope is 7 the whole time, then the area under the curve is, because this is 0, this is 6, is 6 times 7, which is 42. So the area under the curve, if the slope is between 0 and 7, the area under the curve between 0 and 6 could be 0 and 42 or anything in between there. And this right here is going to be between because the slope changes. So the slope is going to change like this. So the area under the curve is not 42, but that's the greatest it can be. Okay. And it's not 0 because obviously the slope isn't 0 for the whole thing. The slope is varying. But I do know that the area under the curve is somewhere between 0 and 42. That's what I've established. Okay? So I got this part here. So now this equals this, right? So now 0 is less than or equal to f of 6 minus f of 0, 42. Because fundamental theorem of calculus says this part equals this part. Okay, so I know that this is 20 because I got that from the original problem. So f of 6 minus 20 is less than or equal to 42. So I add 20 on all the sides, 20, 20, 20, and 0 is less than or equal to, sorry, 20, my bad. 0 plus 20 is 20. 20 is less than or equal to f of 6, which is less than or equal to 62. So f of 6 has to be between 20 and 62. It cannot be 70. So this right here proves that f of 6 cannot be 70. There you go. And that's my justification. So if you are confused about this part, rewind it, go over it again, and see if you can figure it out. Okay? If you're still having questions, text me and I will help you. Okay? That's the toughest problem. All right, let's do C now. Let's do C. All right, looking good. So this right here, so I need to find the integral between 2 and 4 of f double prime of x dx. So this looks weird because why the hell would they have the second derivative? Well, the second derivative, if I'm finding the integral, that's the first derivative. And this is all the first derivative of all these values here. So that's going to work in our favor because this equals f prime, because that's the antiderivative of 4 minus f prime of 2. And f prime of 4 is 1.7, easy, minus f prime of 2, which is 2. So 1.7 minus 2 is negative 0.3. Bam, got it. And that's it. Part C is easy. Okay, last part, part D. It asks you to find the limit as x approaches 0 of all this fun stuff. Okay, so I'm just using the same principles we know. So the limit as x approaches 0, you just plug in the 0 to start. So that's f of 0 minus 20 e to the 0 over 0.5 f 0 minus 10. Okay, so this equals f of 0 is this. Here is 20. So that's 20 minus e to the 0 is 1. Anything to 0 power is 1, so that's 20 minus 20 here. Over half of f of 0, so it's half of 20, which is 10 minus 10, which is 0 over 0, indeterminate. Hello. Okay, so indeterminate. You have two options. What's one? You can factor. What's another? You can find the derivative using L'Hopital's rule. Well, I don't know how the hell to factor this, so I'm going to use L'Hopital's rule. So I'm going to do my work up here. So the derivative of the numerator and derivative of the denominator, that's what we're going to do. So this is not a quotient rule. You don't use the quotient rule when you're using L'Hopital's rule. You find the derivative of the numerator or the denominator as they're separate, okay? So it's not quotient rule. So it's the limit as x approaches 0. So the derivative of the numerator is f prime of x. What do? We write this down first, right? We write this whole thing down. Minus 20 e to the x. Then we multiply by the derivative of the exponent, which is 1, which really does nothing to it, right? Over derivative of the denominator, 0.5 f prime of x minus 10, the derivative of 10 is 0. So I'm going to leave that the way it is. Okay, so now I'm just going to pluggy plug again. So it's going to be f prime of 0 minus 20 e to the 0 over 0.5 f prime 0. Sorry, let's write that a little bit more clear. 0.5 f prime 0. All right, f prime is 0. Boom, I go over to my chart. That equals 4. Okay, so this is 4 minus 20 to the e to the 0 is 20 over 0.5 times 4. Bam. So that's negative 16 over 2, which is, boom, negative 8. Got it. There you go. So that's all the parts. Great job. Rewind anything you were confused on. And do this one again. This is a great one to practice because this one's on the AP classroom, which is going to be on the AP. Nice job.